to see everybody here. It's nice to be able to get to see old friends and colleagues again.
And our residents as well. You know, we're
30 stories worth of fire hose seems like a lot, doesn't it?
Anybody wants to talk to Tom or about what that looks like, the fire stopping elements we're putting in buildings.
That's another sort of energy sustainable technology that sort of is great but works against us. It also burns the grass in my yard.
So the topic that I've chosen to explore is the relationship between sustainability and fire safety in facades. So my name is Simon Bate, and I'm currently a facade engineer working with Buro Happold. And for those of you that don't know us, we are a multidisciplinary engineering consultancy with specialist teams in facades and fire, and with over 2,000 employees worldwide. So more than ever before, we are aware of the crucial role that facades play in fire safety, and at the same time, we're also aware of the huge impact of construction in relation to carbon emissions. So the World Green Building Council states that buildings are currently responsible for 39% of global energy-related carbon emissions. So about 3/4 of this is from their in-use or operational emissions, and the remaining quarter from materials and construction. And I think there is a general impression within the industry that there is a conflict between sustainability and fire safety. And the current perception, I think, has really been tested with works, obviously, to remediate higher risk buildings because of the use of timber and case studies of fire spread in timber facades, and also with the history of combustible insulation as a direct response to the addition of sustainability targets. So in this presentation, I'm going to go slightly less technical than some of the other talks, but I'm going to be providing an introduction into embodied carbon and operational carbon in facades. And then I feel like it's a topic that's pretty well understood within the facade industry now, but I think it's something that we should all really have a baseline knowledge of because it's so important. And especially as facade and fire consultants all end up contributing towards the sort of final selection of different systems. So then I'm going to be looking at embodied carbon in new buildings and operational carbon in existing buildings, and looking at how these may affect fire safety and how we can reduce the carbon. So firstly, what do we mean by embodied carbon and operational carbon in facades? Well, considering embodied carbon first, this relates to the total greenhouse gas emissions generated to produce a built asset. So the first thing to note here is the measurement is kilograms of CO2 equivalent. So this doesn't just consider carbon, it considers all of the greenhouse gases in the assessment. Now, in terms of the actual assessment, we can break this down into the whole carbon life cycle. We can break that down into 4 stages. So we've got product, we have construction, we have use, and we have end of life. So your product phase is going to consider the emissions relating to the manufacturing processes. So that might include obtaining your raw materials, their processing, basically forming a product that becomes part of an assembly. We then have the construction phase, which is transporting your materials to site and their installation on site. And then we have the in-use phase, where this is relating to potentially aspects such as the service life or durability and how often we need to replace these components. And then we have the end-of-life phase. So this is once we want to replace a facade or demolish a building, we need to consider the deconstruction, the processing of the individual components, and then potentially their reuse or their disposal. And I'm sure many of you will have heard of terms before, such as cradle to gate and cradle to cradle, and these relate to which of those stages we are considering within this assessment. On the other hand, operational carbon, a little bit more simple, and it relates to the total greenhouse gas emissions generated in the operation of a built asset. And as I've got on the slide, that includes elements such as temperature control, ventilation, lighting, water, and electricity. And I think the key thing to note here is that there is no golden sustainable facade solution. There is not one system that's best for every project, because there's so many different factors that go into making up the assessment. It's something that really needs to be considered on a project by project basis by a facade engineer, alongside many other advantages and disadvantages. And one of those will also be, one of the considerations will definitely be fire performance. But why should we worry about facades? Well, in terms of embodied carbon, facades can account for anywhere from 10% to around 31% of the total embodied carbon of a building. Clearly, when we look at new builds, structure will be most likely the dominant source of embodied carbon, with facades second in the list. But for refurbishments or reclads, and when the existing structure is maintained, facades will actually often form the largest source of embodied carbon in a project. And facades are also critical for operational carbon as they control heat losses and prevent overheating. In recent years, and this is related to the graph at the bottom, there's been a shift towards decarbonising the grid. And as a result of this, the share of the operational carbon within buildings has decreased significantly, and it continues to get smaller. But this has brought now a bigger shift to think about the embodied carbon, because it becomes a greater share out of the total carbon emissions of buildings. So this is the final slide of the introduction, and moving on to looking at guidance and targets, the operational carbon side of facades is pretty well covered in documents such as Approved Document L, where we have clear targets, for instance, for thermal performance. In relation to the climate emergency and embodied carbon, the UK government set out a target to achieve net zero carbon by 2050. And buildings obviously play a key part in this, which is why we have seen the development of several new standards and targets that set out a roadmap to achieve this net zero carbon future, such as LETI and the REBA 2030 Climate Challenge. And we're already starting to see this being rolled out on projects, such as in planning requirements, where we have quite a lot of scrutiny on how we evaluate our design decisions to show that we have considered carbon. But we're also seeing many more companies create their own targets in relation to sustainability. So, for example, Buro Happold's targets are on the screen, and these include a goal to design all new build projects to be net zero carbon in operation by 2030. But as a final point on this side, you may be surprised to know that there are currently no legislative requirements to reduce embodied carbon on projects. So now that I've provided an introduction into embodied carbon and operational carbon, I want to focus on embodied carbon, particularly in new buildings. I think we generally have a good understanding of operational carbon in new buildings, and as I just mentioned, there's clear guidance to follow, and engineers are great at coming up with solutions to ensure that safety and fire performance are not compromised, even with very high-performing projects. But as I mentioned at the start, because of the high impact of new projects, it's really important that we look at the embodied carbon, particularly for new buildings. So on the screen, I have some examples of embodied carbon calculations for some different facade typologies. So two are more traditional methods of construction with a brick cavity wall and brick face precast, and a more modern method of construction with a brick slit rain screen. And even though these systems appear the same externally, or very similar, they can have strong impacts on both the embodied carbon and the fire performance. And the first point I want to make on this slide is that the insulation, boarding, and the other small components actually account for a comparatively small percentage when compared to the total embodied carbon. So we're being increasingly encouraged on projects to look into alternative materials through the whole depth of the build-up, for example, wood-wool insulation or other materials that may be combustible. But really the question is even if materials fall within the certain fire performance requirements we need to meet, can the sustainability benefit be justified overall from a fire safety perspective? And the next point I want to make is that I think most people would assume that because a brick slit rain screen is a lightweight system, it's actually the more sustainable solution. But actually, when we look at the figures, we can see that because metal is the highest contributing factor, and because there's such a dense arrangement of subframing behind a brick slit rain screen, it could be that a brick slit rain screen has a higher level of embodied carbon than brick face precast. And of course, we also do need to consider the embodied carbon of the structure too. But the use of these more modern construction methods, and as that increases, with systems that may be perceived to be more sustainable, this can then have further implications on fire performance, for example. For example, if we just take the systems that we've looked at, with a brick cavity wall or brick face precast, the solutions at the slab edge to provide compartmentation are pretty robust and well understood. They're simple solutions. But then if we look at some brick slit rain screens, we can start to encounter difficulties when we want a surface for the cavity barrier to expand onto, and we may have a profiled system and possibly also continuous components such as rails passing through that. And clearly, as well as the open state horizontal cavity barrier, this would create real complexities with the design and installation of the vertical cavity barrier in systems such as this. So these are obviously not unresolvable. We've seen them on projects and have solutions to overcome this, but they do create a much higher level of complexity in relation to the design and installation of fire critical components. And I think the key message here is that as we implement more modern construction methods, and we're likely to see the development of similar systems in the future to save weight and reduce material, we need to be really conscious of system selection in relation to the fire performance challenges this can present. Simplicity is key. But of course, another way that we can reduce the embodied carbon of the system is with alternative materials such as timber. Obviously, over the past few years, timber is a material that has been subjected to a very high level of scrutiny in its usage within facades, and unfortunately we do have case studies where timber has resulted in significant and rapid fire spread. And clearly the updates to the approved documents do create tighter rules around its implementation, but do allow timber cladding at least 9 mil thick to be used below 18 metres on non-relevant and non-residential buildings. Of course, the alternative route is through a full-scale fire test, and this is why testing of representative facade system build-ups is really essential if we want to see more usage of timber materials such as timber. But I think the key word here is representative, because we've seen examples of tests where the method of installation on the test rig perhaps would not be reflective of the actual on-site installation. So at that point, it's as good as useless. But the difficulty with this is even though the table on the previous slide states that the usage of timber is acceptable, section 10.4 of ADB says that consideration should also be given to the choice of materials used for the external wall to reduce the risk of fire spread over the wall on buildings of any height or use. So really, this is going back to the overarching regulation of B4. Even though ADB may state the usage of a particular material is suitable in a particular scenario, we then have to evaluate whether we're being compliant with the overarching regulation. And this then becomes an assessment based on factors maybe such as the overall project context or occupant usage, or maybe we have the full-scale test data to support the assessment. But also we need to consider the appetite to take on risk from the insurers. We're seeing insurers become engaged earlier and earlier on in our projects, and some may not be willing to take the risk of the inclusion of materials such as timber. And there's also a lot of research being conducted at the moment into materials such as bamboo. So if we are to implement these within a facade for sustainability reasons, then we need to carefully manage their implementation where the regulatory framework allows and be confident in ensuring that we are not affecting the fire safety performance. Now, green walls have already been clearly covered quite well, and they are a sustainable solution. They have some really strong benefits in relation to biodiversity or air purification, but from the outset there may be little benefit in relation to embodied carbon because with many of the systems they still have extensive metal framing behind. And as I said, we just had a talk on this, so I won't kind of dwell on this point too much, but really there is little robust government guidance on the fire performance of these systems and how we implement them. And this is difficult as there really is the increased potential of a fire risk if their implementation is not carefully managed. And as new systems are developed, this can also create new questions and challenges. For example, if we look at the bottom of the screen there, that's an example of a system that I've been proposed on one of my projects. And this is a system, obviously, where the plants are contained within the pockets and then they have a profile back to them. And straight away you can see from that, it would be an absolute nightmare to start integrating cavity barriers within this system.
Book your tickets now for the 8th International Tall Building High-Rise Fire Safety Conference, taking place alongside FDIC in Indianapolis, US, on the 15th to the 17th of April 2024. 3 days of world-class speaker presentations, debates and networking. Book your tickets via the website www.tallbuildingfiresafety.com. Early bird discount tickets will be available. The Tall and High-Rise Building Fire Safety Management course is ideal for anyone who has responsibility for fire safety management in tall and high-rise buildings. It is a 5-day intensive course with world-class instructors. You can get full details of the course on our website www.tallbuildingfiresafety.com.
We also need to bear in mind that with, for example, a concrete facade, I know that the fire performance of a concrete facade is going to be the same in the UK if I take it somewhere like Greece. When it comes to green walls, how can I be sure that the performance is going to be the same if I take it to a different environment? And it then brings into question testing and the applicability of the test procedures that are in place. And the final point I want to make on this is that obviously with many of these systems, periodic maintenance is required, or access is required to maybe repair the irrigation system or trim the plants. With a normal facade, if the access and maintenance system isn't upkept and it doesn't have the necessary certification to be used, which we do see quite frequently on projects, a facade might become dirty or a panel maybe can't be replaced. With a green wall, this would mean that you can't trim your plants, you can't repair that irrigation system, so this increases the fire risk. So clients or the management company need to understand that some systems may come with additional responsibilities, and this will create an additional cost that needs to be allowed for from the outset. But moving away from solid build-ups to glazing systems, on the screen I have a typical breakdown of the embodied carbon of a stick system. So this is a double glazed unit with laminated glass. Clearly the major contributors to the embodied carbon are the glass and the metal. The other components actually account for a very minimal percentage. So there's not really too much there we can do to reduce the embodied carbon. With the glass, we can look into the use of low carbon glass, and that uses recycled glass cullets. And that's a saving we can make on the embodied carbon without having any impact at all on the fire performance. But then when we look at the metal, that's where we have to consider potentially the use of timber alternatives. Now, Regulation 7.3 exempts door frames and window frames, so clearly the regulations say that we can use timber in certain scenarios. Of course, we do have to be careful around spandrel areas, but clearly by switching from metal to timber, we are increasing the risk in relation to fire safety. And this is, again, where we may have difficulties in reducing the embodied carbon of a system without affecting the performance. And I'm certainly not saying that timber shouldn't be used within these systems, but clearly in this instance, to have a more sustainable solution, there may be an increased risk in relation to fire safety that needs to be carefully managed through both the design and on-site. And this is where the golden thread comes in, and where it's important that we create a record of the decisions that have been made on a project and on what basis to extend all the way from design and throughout the life of a building. And we may then need to consider aspects such as the exposure of the system, the building usage, or the continuity of the system across the facade. For example, with the image at the bottom of the screen, if we have small punch windows that are widely spaced, clearly that will present much less of a risk than more closely spaced windows or systems that are continuous in front of the slab. But overall, we need to be sure that we are meeting the requirement of B4 and ensure that the insurer and other key stakeholders are comfortable with the usage of timber or other materials in this way. But to finish off the section on embodied carbon, there are also so many ways we can reduce the embodied carbon of a facade without affecting the fire performance in any way. A number of these are identified on the slides, but just to highlight a few, we can consider embodied carbon earlier on in the construction process, following the process of build nothing, build less, build clever, build efficiently. We can also design efficiently, or we could design a facade that can be easily disassembled so that the end of life components can be easily removed and processed separately and maybe even reused. And moving on to existing buildings, when it comes to existing buildings and remedial projects, the focus is often on operational carbon. We already have a structure that's built, and in many projects we also retain the backing wall. So we have a limited ability to influence the embodied carbon, especially if the same aesthetics are being maintained externally. And in order to reduce the embodied carbon, we need to provide an increase in thermal performance by adding insulation. But as we do this, we need to be careful that we do not increase the fire risk. We need to improve the existing fabric without compromising on fire safety. And this is where in the past combustible insulation may have been added to satisfy the requirements of Part L without consideration of the impact on fire safety. And although in the UK there are strong requirements on the fire performance of insulation, there are still countries where the regulations are more relaxed and decarbonisation programmes are increasing the fire risk with materials such as phenolics or EPS being added externally to buildings. But with remedial and existing projects, before we can even begin to consider creating a sustainable and fire-safe design, we have to carefully analyse what we already have, as there can often be a number of complications. We need really to take a three-phase approach to the remedial works. We have firstly to review the information that's available, or this could be through opening up investigations on site. Then we need to assess the compliance of the existing building and determine maybe those locations where remedial works are required, where there are weaknesses in the current fire strategy, or perhaps where the as-built, on-site conditions deviate from the as-built conditions. And then finally, we have an implementation phase, and this is where we can then think about designing and implementing any remedial works in a way that is sympathetic to the environment and doesn't increase the fire safety risk. Now, obviously, a large portion of the projects within the fire industry at the moment are related to the reclad of existing structures, and with the pilot opening of the medium-rise scheme, it looks like this will continue for a long time to come. And this is where in that assessment phase we can use timelines such as this on the screen to aid our understanding of what materials may be present within a facade and therefore where the risks may lie. So to avoid increasing the operational carbon in existing buildings, it's essential that we maintain the thermal performance of the envelope. And why can this be an issue? Well, the typical phenolic insulations that we often encounter, despite their poor fire performance, actually perform better thermally than the typical replacement of mineral wool. And this means that in order to maintain that performance, we actually need to thicken the insulation layer when we're replacing it with a non-combustible alternative. From the graph on the screen, it's also clear that the better the thermal performance target we have, the greater the difference in insulation, insulation thickness we need to provide in order to maintain the same target. Now, there are some products out there that will provide a comparable thermal performance with, say, phenolic insulation with a good fire performance, but they tend to be more expensive, can have significant environmental consequences, and are definitely less commonly used than mineral wool. And even though we may be reducing the fire risk typically, we may be creating additional design complexities that could affect the fire performance. For example, if we take a typical slab edge scenario for a brickwork outer leaf and an SFS inner skin, so this is a fairly traditional solution, we may have a phenolic type insulation and we may or may not have a cavity barrier at the slab edge. When we then maintain that thermal performance and replace this insulation layer with mineral wool, we then have to push out the layer of brickwork and then we have to have a larger bracket to pick up the brickwork because we've then pushed it out. And suddenly we don't have space at the slab edge to run a cavity barrier continuously over these brackets. So there is a potential weakness in the fire performance of this detail because our cavity barrier will obviously be interrupted with these brackets, and this is likely not to be part of a tested solution. Of course, if this is to be done on new builds, then there are design solutions that can mitigate the problem altogether. But with recladdings, we're often limited by the existing structure and also whether we can alter internal linings. For example, there might be residents that we can't disturb at the same time. So it's at these points where sometimes a holistic view has to be taken on the fire performance. Of course, we will have increased heat transfer locally through the bracket at the slab edge, but we could argue that overall the fire risk has been decreased because we have removed the combustible material. So that's just one example of where we may be limited by the constraints of a particular project and therefore unable to find a perfect solution. But sometimes we may have to look at the whole picture holistically, and it can be a balancing act between ensuring that a fire-safe solution is implemented and that the existing performance is maintained. And I wanted to include this graph because sometimes, of course, there may not be a solution with existing buildings. There may not be a way in which we can keep the same performance and remove or mitigate the fire risk completely. And this is where fire safety definitely has to come first, and over time, as we decarbonise the grid, the energy actually gets cleaner anyway. So the environmental cost of perhaps a marginally worse performance will be less severe. And of course, sometimes there will also be a hybrid or a sweet spot where we can accept a small reduction in the operational performance, but in doing so, we ensure that we don't have an impact on the fire performance. And the final aspect that I just wanted to touch on was the importance of site installation quality. Now, this is so important anyway, but in the first half of the presentation, I talked about cases where we may be including combustible materials within the facade zone, provided that these are permitted by the regulatory framework and the risk can be managed from a fire safety perspective. And in those instances, installation of fire critical components becomes even more important. And from my site experience on recladding projects within the UK, sometimes it can be really quite surprising what we encounter on site, whether it's because an area hasn't been detailed and builders have tried to improvise, or whether the guidance of the product manufacturer has simply not been followed. So I think it's really important for facade and fire consultants to have a scope in relation to site visits during the construction period, because otherwise there may be locations with very complex details that could fall through the gaps, especially with modern construction methods and some of their complexities. And obviously with the overhaul of the Building Safety Act, we could also see requirements for mandatory reporting depending on the severity of these issues. So it's vital that we ensure the documentation also at the end of a project is organised and accurately records the as-built conditions and the design decisions that have been made during the design and construction process, so that when we come back to projects in the future, we have an accurate pack of information that clearly captures what has been constructed. And we see this even with projects that are built 5 years ago, 10 years ago. The way the information is stored and whether all of the information has been included is generally very poor, and there's often sections that have been left out. So the key takeaways from this presentation are that we really do need to reduce the embodied carbon of new buildings and the operational carbon of existing buildings without compromising on the fire safety. And there are many methods that we can use to do this that do not impact the fire safety risk at all. But this doesn't mean we should altogether abandon the use of low carbon alternatives such as timber, even if they do have a high combustibility. We need to understand how these materials perform within systems and design with them conscious of minimising the risk. And as I've just said, with simplicity in the design being the key. And clearly what I've discussed today has been about considering embodied carbon within facades, but the question that I would like to leave you with, as I know many people within this audience are fire consultants, is when presenting different fire engineering solutions to clients on a bigger picture within a project, how often does the impact on sustainability, maybe aside from cost, such as embodied carbon, form part of your consideration? Thank you very much for listening.
Book your tickets now for the 8th International Tall Building High-Rise Fire Safety Conference, taking place alongside FDIC in Indianapolis, US, on the 15th to the 17th of April 2024. 3 days of world-class speaker presentations, debates and networking. Book your tickets via the website www.tallbuildingfiresafety.com. Early bird discount tickets will be available. The Tall and High-Rise Building Fire Safety Management course is ideal for anyone who has responsibility for fire safety management in tall and high-rise buildings. It is a 5-day intensive course with world-class instructors. You can get full details of the course on our website www.tallbuildingfiresafety.com.